Hello, everyone. We're going to get started. If this is your first IAAPA webinar, welcome. And if you've joined us before, welcome back. Thank you for attending today's session, Reimagining Storytelling, Transforming Experiential Spaces with Large Format 3D Printing, presented by Massivit. Really excited to have this discussion today. And my name is Brian Tierney. I am the Global Education Senior Specialist here at IAAPA. And today we are excited to explore how large-scale 3D printing is revolutionizing themed entertainment, character creation, and immersive environments. From theme parks and museums to live events and brand activations, Massivit's cutting-edge technology is empowering creative teams to build imaginative, large-scale experiences faster and more efficiently than ever before. And make sure to check out Massivit's booth at the IAAPA North America conference coming up here. They're going to be at booth number 1357 next week, so make sure you check them out. Now, before we get started, let's take a few moments to explain today's webinar format. Now, today's broadcast, you'll be able to view and listen to the presentation, but your microphones and cameras will remain off throughout the session. There is no charge for listening via your computer, but please note that if you've dialed in by phone, long distance or international rates could apply. Now, you also have the opportunity to submit questions to Massivit throughout our presentation by typing them into the Q&A control panel that's going to be located at the bottom of your screen. Now, you're going to see the chat box as well, but don't put your questions in the chat box. You want to put it in the Q&A panel instead. And we'll address as many of those questions as we can towards the end of our presentation today. We are also recording today's broadcast, and the recording will be available on the education page at IAAPA.org in approximately 3 to 5 business days. So feel free to share that information with any colleagues who could benefit from today's session. Remember, IAAPA webinars have access to a large library of past webinars and education sessions, all free to our members. So make sure you take advantage of that and check that out. Participation in today's webinar also counts towards continuing education credits for IAAPA's certification renewal. If you'd like some more information on IAAPA certification, please check out IAAPA.org. And now I am honored to introduce our speaker for today's webinar. We have Pieter Machtelinckx, Head of Operations and Marketing for EMEA at Massivit. With an extensive background in 3D printing and advanced manufacturing area, Pieter is driven by aligning technology, people, and strategies to accelerate Industry 4.0 transformation. At Massivit, he helps manufacturers adopt large-scale 3D printing solutions that automate production, reduce costs, and enable sustainable, customized fabrication. Pieter works closely with partners and clients across Europe, the Middle East, and Africa to bring large format 3D printing to life in themed entertainment, fabrication, and experiential design. Now, at the end of our presentation today, when we get to the Q&A, Pieter's going to be joined by one of his Massivit coworkers, Fabio, who's going to help answer some questions. So we'll meet Fabio in a little bit. But for now, Pieter, I'd like to toss things over to you. Take it away.
Yes, hi everybody. Thank you, Brian, for the nice introduction. Let me get my screen up. Yes. So yeah, hi everybody. Thank you for joining us today. Today we're going to talk about 3D printing and more specifically on how it can be a very valuable tool in storytelling. Because every great experience starts with a story, and every story deserves to be felt, not just told. And with large format 3D printing, we're giving designers, fabricators, and brands a new medium to bring imagination to life. Whether it's a themed attraction, a museum installation, or a retail environment, 3D printing is transforming how stories are told in space. Because it enables unique shapes, complex textures, and custom designs that were once too costly or time-consuming to produce. And that's what we're going to show to you today. So as Brian already pointed out, I'm Pieter Machtelinckx. I'm the Head of Operations and Marketing in the EMEA region for Massivit. And later on, I will be joined by my colleague Fabio, who's our technical expert. And for sure, we'll be able to answer some questions that are going more in depth on the technical details. For now, just to start, as a publicly listed company, I have to start with this standard disclaimer, because some of the things that we'll discuss today may involve forward-looking statements, essentially. They are projections on the future, and they depend on a number of factors and risks that may cause the actual results to differ. And as Brian already pointed out as well, next week we will be in Orlando, Florida on the IAAPA Expo. Feel free to join us at our booth where we'll be printing live with the Massivit 3000. So you can see the machine in action up close. You will also be able to see some very nice finished models that we will have on our booth. So come and say hi to our North American team when you're there. For the European people, we will also be exhibiting next week in Frankfurt in Germany, where there's Formnext, which is basically the biggest 3D printing trade show in Europe. We'll be there at half 12.1, booth B69. I will be there as well, so if you're in the neighborhood, feel free to pop by and see our machines in action. Now, on to the content of today. First, I'll discuss a little bit on the challenges of custom fabrication for teaming and retail. Then a little bit on the why 3D printing and why it can be beneficial. Then I'll go more into depth into our technology, the GDP or gel dispensing printing. Then we'll have a short technology overview and the materials that you can print with. And then, of course, we'll be looking up close to some case studies, some workflows on how to implement large format 3D printing into an actual production workflow. At the end, of course, there will be some time for Q&A. So to start off, custom fabricators, they are masters of all trades, and they employ many different technologies, tools, and many different fabrication methods to achieve their creative output. And today we'll be addressing how large format 3D printing solves some of these challenges, specifically for themed attractions and the retail theater. So it's the current production methods of manual sculpting, and with the advance of technology, also CNC machines, achieves beautiful results, but it's at a high cost of time, complexity, and consistency. For instance, these methods are quite manual and labor intensive. They often depend on human availability and skilled sculptors. They're quite costly for one-offs as well, because every unique piece means new molds, new tooling, or hand finishing. Some of these methods, they also have quite a lot of design limitations, specifically if you want to create some complex or organic forms. It's very difficult to produce. There's also quite a few heavy and fragile materials involved, specifically, polystyrene or foam or wood. They require a lot of reinforcement or frequent repairs. They're also hard to replicate or to scale because, if you want to create let's say a carbon clone of or many different pieces that look exactly the same, if you do it by hand, it's very difficult to achieve. And there's also the sustainability concerns, specifically material waste. So that's why we think 3D printing is a valuable alternative production method, and we want to start people get to reimagining the craft by directly printing large pieces. The example you see below, it's a Spider-Man that was 3D printed by our customer Media Resources International. It's about 2 meters wide, and it was printed in less than 24 hours. And by directly printing large pieces and complex pieces, you can eliminate much of the time-consuming, tedious tasks that are required to build up and carve large sculpted pieces. Because 3D printing allows these pieces to be produced extremely fast and get to the finishing stage much faster, by providing more time to create elegant, high-quality finishing using your skilled craftsmen and artists. So to compare a little bit the 3D printing versus the traditional fabrication, and how 3D printing solves a little bit these limits of traditional fabrication. So while on the previous slides I showed that the traditional fabrication is quite often manual and labor intensive, 3D printing is the opposite. It's automated, so it's direct clone from the digital design, and it minimizes manual sculpting. Also, instead of being costly for one-offs. 3D printing is also the opposite. It's just ideal for one-offs and limited series because there is no molds, no tooling involved, and just directly printing the material and the piece required. It also unleashes unlimited creativity, so you can create any complex geometries, textures, you can have easy design iterations, etc. It also involves lightweight and durable materials, which allow for simpler logistics and easier mounting. Whereas, wood and fiberglass, they require reinforcement, they're quite heavy. And finally, related to the sustainability concerns, when you're working with a lot of material, 3D printing is basically the opposite. You only use material where you need it, and there is minimal waste, basically, which we will show in a later slide as well. So the business case for 3D printing, it's quite obvious. From design to installation, depending on the case and the design, it can go up to 50 to 70% faster. The pieces itself, they can be up to 40% lighter. There is no tooling costs involved, and also fewer subcontractors, because basically once you have a machine in-house, you can start creating with the push of a button to, let's say. So there is less coordination and less risk involved. And of course, you always have a digital backup of the files at your availability, so you can reuse them, you can modify them for future needs. Just to give a quick example of a project that benefited a lot from these advantages of 3D printing is this fully 3D printed car prototype. It was designed and printed by students in the time frame of less than a year at the SCAD, which is the Savannah College of Arts and Design in Georgia. And they basically used 3D printing and the Massivit machine because there was no tooling costs involved. And it also allowed them to go faster from the design to the final iteration. And it was a very lightweight piece. And this car was displayed at during the Formula One Grand Prix in Austin, Texas. We'll go later in the presentation into much more detail for some projects, but just to come back a little bit on the environmental aspects. 3D printing has quite a low carbon footprint because it allows you to reduce material waste by only using material. So let's say that you want to produce a ball, let's say. If you would produce it in a traditional way, you would start basically with a block of material, and then you start to chip away or cut away material from it. With 3D printing, it's the opposite. You only use necessary material that is required to form the final shape or form. So you only deposit layer by layer this material, which also allows you to make this ball also hollow on the inside, which allows you to have some space on the inside for illumination or electronics if you want to produce some animatronics. Additionally, 3D printing is also a quite, let's say, low on energy consumption. And you can eliminate outsourcing, as we've said, and the associated transportation that comes with that as well. So also there's a gain in carbon footprint. To go a bit more in detail on the technology, which is something that I want to do first, I will not go into too much detail, but just a little bit so you can understand more or less how the technology works. When Massivit was founded, we started focusing on 3 pillars, which is speed, size, and materials. And it's 3 pillars that are not usually associated with 3D printing. Most people know 3D printing as a way to create small objects that evolved into a method for producing, let's say, mock-ups or prototypes. But currently on the market, there is really a wide range of 3D printing technologies available. And we think with our solution that we have something available that's very well suited for the theming and experiential industry. So just to go a bit more in detail, the base material of GDP or gel-based printing, it's gel with the viscosity of a toothpaste or a hair gel. And this process uses our gel screw to extrude the material and move the UV curable photopolymeric gel through the print dispenser and nozzle. And the gel is dispensed at a high speed and it's instantly cured using a UV light that's mounted on top of the extruder. And by instantly curing this gel, the printer can produce extremely large parts very fast, up to 35 centimeter per hour in the z-axis. So that means in some cases, a full-size character of 180 centimeters tall can be printed in under 7 hours, which is quite fast for a 3D printer. I'll go a bit more in detail on the printer later, but just to give a quick overview, I'll show this video. Yeah, so to give a short recap, I'm from Europe, so I was talking in centimeters, but I know there's also some people from overseas watching. So we can print a 180 centimeter part or a 6 feet part in less than 7 hours. And the vertical build speed of the machine, it's 14 inches per hour for 35 centimeters. And the build envelope of the machine, it's more or less 1.1 by 1.5 by 1.8 meters in height. Of course, you can also create bigger parts in 3D printing because the files are digitally. You can split them up into several different segments, and then you can join them together later. This is an example of a statue that was put in Portugal in front of a train station, just as something to get you thinking on what are the possibilities of large-scale 3D printing. Just to give a short overview of the printing materials, basically, because we talked about speed and build size, but we haven't mentioned really the third pillar. We have a quite wide range of materials available. The most effective or cost-effective one is the Diamond Gel 90. We also have Diamond Gel 100, which is translucent, which is very nice for some channel letter applications, for instance. There's Diamond Gel 300, which is completely transparent, if that's what you need. And there's a few others, for instance, the Diamond Gel 110, which allows you to print in a very high resolution, or the Diamond Gel 400, which is basically an enhanced impact material that's incredibly durable. And now to go a little bit more into some details of how the workflow goes with 3D printing. I want to explain it by using a case that was done by one of our customers in Mexico called AdSpace. And they were tasked by producing some statues for the launch campaign of Money Heist or La Casa del Papel for the 5th season of the show airing on Netflix. So basically, the workflow for 3D printing is always the same, whether you're using our technology or another one. It remains the same. You always start from concept and design from a digital file. You go through file preparation, slicing, the printing, the post-processing, and then the actual finished part. So for this project, AdSpace chose to use Massivit instead of hand sculpting or CNC machining because it gave them several advantages. First of all, it allowed them to produce a precise one-to-one recreation of the client's highly specific design ask. They were also able to schedule significant parts of the production process to run unattended, so overnight, which was critical because the project needed to be finished in a very limited amount of time. And also, by using 3D printing, they reduced their carbon footprint, material waste, and health concerns dramatically. So the first step is, as I said, the concept and design. So basically, you need a 3D file to start from. This can be done either by creating it from scratch in CAD software, but you can also capture the geometry via 3D scanning by using a static scanner or a handheld scanner. That's always the first step. The second step is then once you have a 3D file is basically to prepare the file, because specifically when you use a scan, these scans, they capture a lot of detail, but they contain some noise and some imperfections that require cleaning. So in this case as well, the AdSpace team, they smoothed and refined the model carefully to preserve the anatomical accuracy of the models, but they repaired basically what we call the mesh of the file to ensure they had a watertight geometry and eliminate some issues that affect printability. Then they moved on to the slicing, which is basically software that comes with any 3D printer. This allows you to, let's say, cut the model into the different layers and define the print parameters such as the layer height. So if you want to print a file very quickly, you may use a very coarse layer height. If you want to have more attention to detail, for instance, and the printing time doesn't matter so much, you'd be better off using a smaller layer height in the z-axis because it allows for much more detailed prints. Sometimes if models are very large scale, such as the statue that I was showing earlier in front of the train station, you may also need to develop a strategic approach to split the model into multiple optimized sections. So specifically with the Massivit 5000 that we offer, it has dual print heads, so you can take advantage of this by printing two identical or even two unique parts simultaneously. And in this step, you also plan the print orientation, basically how you put the file on the machine or what makes most sense. But Fabio can get into more detail later on.
Yeah.
So here you see our software. It's basically showing layer by layer what the end result will look like. And then the fourth step is the actual printing or the actual fabrication. So the printer builds the object layer by layer. So it deposits material on a build table layer by layer according to the sliced file. And you see the part basically grow almost magically until the print is fully finished. When you have to take the part out of the build plate, basically. And then comes the fifth step, which is post-processing. It requires usually some sanding, some curing, or some polishing, because basically with every 3D printing technology, you always see these fine layer lines in the printed model, because 3D printing, is building the model layer by layer. So you might need to sand this away or put some coating on it to make the layer lines less visible. And then there's also, depending on the use case, in some cases, you need to apply some fiberglass to the seams, or you can add some internal support structure or some foam on the inside for added stability. Depends if the end result will be put in a place where, let's say, a lot of people will have access to it and try to touch it, and where there needs to be a bit more durability. And then basically after strengthening it, if necessary, or sanding the model, you can apply some primer or some paint. And then here you see some of the people from AdSpace putting some coating on the part as needed. And then basically on the right picture on the right-hand side shows the final model before it was put on display. So that's the last step to install the model, of course. Some other examples I will show quickly. These ones are in the amusement park and museum space. The first one was a Triceratops. It was done by our customer in France, Metropole. I've seen it up close, and it's really amazing. The finishing is very nice. It's quite impressive as well because it's 3 meters tall as well. It was printed in 51 hours, and besides printing, the only thing that was done to it was some clay and some painting to recreate the texture of a dinosaur skin. Another one is a Transformer statue that was also done by a customer of ours in France, close to Paris, Marie Tradet. This one, it's also quite high, 2.5 meters tall, was printed in 70 hours, and we used 35 kilograms of our gel material. This one, it's a nice example. It was done by our customer in Belgium, Fisheye. They did it for the Plopsaland theme park in the Panne in Belgium, because they basically used a lot of different fabrication methods to come to the actual end result. So they did some teaming for a dark ride. Some parts were 3D printed because it made more sense to print them. Other parts were more done by hand because it's they still have a lot of manual sculptors in their facility as well, and they tried putting the technology at use at the place that was most suitable for it. So the head that you see here, for instance, was 3D printed. We have another customer that's doing in the Netherlands that's doing the same. They're printing some body parts and some covers for animatronics as well, because basically our printing technology allows you to print completely hollow parts. Some other examples of the finished product here, where you see some before and after shots of it. Another nice example, it was this time tree for the Singapore bicentennial celebrations. Also very, very large parts. As you can see, the tree stump was printed in 150 hours, which also seems like a lot, but basically because the machine can print unattended, it's just an extra worker for your availability. It was strengthened on the inside as well. The tree ring is also 3.5 meters tall, and it was printed in 90 hours. And in the next picture, you can also see that the designers took advantage of the fact that the Diamond Gel 100 material is translucent, so they put some very nice lights on the inside. Another very nice example is an Australian Aboriginal soldier memorial, and it's very nice as well because they also needed to produce this in a very short time frame, and basically the people from Three Dreams told us that sculpting would have cost them 30% more and would have taken a lot longer to produce. So they managed to finish it with some faux bronze patina. They filled the hollow model with concrete and then coated it with fiberglass just for the durability, because the goal there was to have it as durable as a real bronze statue. Some other examples from film, TV, and theater. The first one is from the show The Orville. They actually use this as a prop in the movie, the TV series production. This one was printed in 168 hours by Dangling Carrot Creative. Another one, which I like as well, is it's this one. It's a flying car for the famous La Scala Theater in Milan, in Italy, for the Don Pasquale opera. Basically, they needed a famous car, the Lancia Aurelia Spider, from one of the most iconic car scenes in Italian cinema. But the real car, which is was too expensive. It's a very, very expensive old-timer. But it was also too complicated and too heavy to hang from the ceiling, because in this opera production, they wanted the car to come down from the ceiling, as you know, basically the same as you see in the animation here. So they were thinking of other methods to replicate this car. They first were trying to do it in wood, but it was impossible to carve it from wood in the time frame they had available. Then they were thinking about polystyrene, but that would also not be possible, because it would be impossible to make it hollow, so the actor could not sit inside the car. And that's when they came up with the idea to do it with 3D printing. And the whole car was basically printed in 96 hours. And there was some sanding and some painting done, but that was basically it. So they managed to finish this prop in a very short time frame. Another example is this one. It's an illuminated decor for Storyville in Australia. These are very large mushrooms that hang from the wall. As you can see, they're 4.4 meters by 4.3 meters wide. And also because the GDP technology allows to print hollow parts, it was possible for them to put some LEDs on the inside. So basically they painted the models, put some LEDs on the inside and hung it to the wall, which creates this very nice effect, as you see here as well. Another example, which is already quite an old one, it's I think it was done almost 10 years ago, but it was a bus advertising produced for the Angry Birds movie. I like to show it because even though it's old, there's a nice video of it, which I will show later. It was done by our customer Charisma, but it's basically a combination of different techniques. So they used vinyl wrapping and printing, and not only did they use direct prints, but they also printed for the beak of the bird. They printed a mold and then used thermoforming to produce it. So it's another way of using 3D printing as a production method. I'll cut the video a bit short. I think you're basically getting what this is about. And a final example in this space is one produced by our customer Pink Sparrow in the US, which they did for the TV show Stranger Things. On the right-hand side, you see the model, which was basically cut in two, the head and the rest of the body. They cut it in two because it was too big to fit into the machine, but because the gel that we print with, it's curable with UV light, we can also use this gel as a bonding agent with a UV flashlight. So basically you can print one part and then print another part, so slice the part in two, but then use the gel as some sort of glue to basically bond the parts together. I will also show a video on Pink Sparrow on how they're using the machine in various different projects. They actually have two machines, not one. So they bought one and they were, so happy with their 3D printing capabilities that they bought another machine.
Hi, I'm Anthony Santiago, and I'm the president of Pink Sparrow. The clients choosing between sculpting and 3D printing is shifting much more towards 3D printing. They want a more one-to-one replication from their models to the finished product.
The possibilities are endless with the Massivit 3D printer. It unlocks creativity for our clients and for our design team. Projects that benefit the most are those requiring large-scale, visually impactful elements for trade shows, retail environments, event marketing, or even prototypes. If a project demands speed, scale, or visual drama, the Massivit is a great option.
The ROI on the first machine has provided meaningful business results. The second machine gave us true bi-coastal capability, allowing us to replicate output, manage multi-market campaigns more efficiently, and reduce freight dependencies. It also enhanced our ability to deliver faster and more sustainably while maintaining full control over scenic quality, finishing, and consistency from coast to coast. The Massivit has provided new opportunities with existing clients as well as new clients by expanding the industries that we're able to serve, mainly our entertainment and brand direct clients like Netflix who have very specific IP that they want replicated exactly. Pink Sparrow would not be able to service those clients without having the Massivit.
Some of my favorite results that have come from the Massivit printer are the Marc Jacobs hand that we did for Dover Street Market. Second would be the large Gymshark statue that we did. Both of those were really fun to work on and looked amazing in the end.
Having this tool in-house has proven to be a strategic differentiator in our business development conversations. It helps secure products that might otherwise go to outside vendors by combining value, control, and innovation under one roof.
Okay, so just a few more final, let's say, applications and case studies from the events and exhibitions industry. This one is Starfighter from Star Wars. It was 3D printed by Danglet Carrot Creative again. It was made for the Comic-Con Expo. Some more pictures here. This was a very nice project because it was contained a lot of details. Printing time was 230 hours, more or less. And there was also some strengthening on the inside because they allowed people to sit in it on the trade show. We basically got a very nice testimonial from the CEO of Weta Workshop, who were involved with the project as well. Because he said, for 15 years, we've dreamed of a day when a printer would provide super large scale, speed, and build strength at low print costs in equal measure. And the Massivit 3D printer has delivered this for us. So yeah, always nice to get a testimonial like this. Another example is this 2-meter astronaut prop that was printed by our customer in Barcelona in Spain, Adecco. It's around 2 meters tall as well, so it's life size, and it was printed in 45 hours. You can see some pictures of the printing process on the right-hand side. Some other examples, so party props for a skiing trip as a selfie point. The ski boot was printed in 38 hours, and it also had the capability for people to jump inside and take some very nice selfies. Same with the goggles that were also used as a prop for a picture opportunity. Another one was produced by our American customer Eclipse Corp for a Burger King, a throne of fries, small pun to a very well-known TV show. Was printed in 58 hours and was also painted and filled, and they had casters on the bottom for easy movement. A very nice example here, it's from the Festival of Lights in Guadalajara in Mexico, a very, very big piece, over 8 meters wide, was installed into a water tank as well. So there was some waterproofing added with the paint for the material to be able to stay underwater for a long time. Even though our diamond gel by itself, it's already hydrophobic. It's an acrylic-based material. So there's not a lot of difficulties of putting it into the water. Another nice application of 3D printing, it's to be able to do some projection mapping. Like this example, a rocket also produced by Adecco. So they produced it for a trade show. And then there was a beamer hanging on top of this model, and they did some nice visuals on it. And then finally, some examples from the gaming world. This one, it's a gaming cockpit that was installed at the Computex trade show. It was printed by Sit Installation Art. Printing time was 110 hours, and people could basically game inside of this cockpit on the show. And then another one, this is not an example of large-scale printing, but it's just to show you that you can, these complex hollow shapes that are almost nature-like. You can also do with 3D printing. So it's an ATX chassis for a gaming computer, which is also a very, very nice example. So before we delve into the Q&A, maybe just quickly on our company, we were founded over 10 years ago by some industry pioneers, basically with the goal, as already said, to introduce large scale and very fast printing to the industry. At the moment, we have over 220 printers installed in 40 countries worldwide. You see some of our customers here in many different industries. Also, let's say in the marine industry, in transportation, in various industrial areas. And that's it basically. So thanks for joining us, and I'm happy to switch over to Brian again for the Q&A.
Thank you so much, Peter. In fact, I'm going to bring someone else to join us in this Q&A discussion. We're going to bring Fabio Lorafici over here. Fabio is a demo manager and service coordinator for Massivit. Fabio, it's great to see you. Thanks for joining us today.
Hi, Brian. Good afternoon. And good afternoon to everyone. Well, depending on
Hi.
your,
All right. So we do have some questions rolling in, but I would like to throw it out there. If anyone's suddenly got a question popping up in their mind, head on over to that Q&A panel at the bottom of your screen. We'll see if we can't get to that question for you. So let's take a look at our first question here. We have, what is the difference between gel and resin from the sanding strength perspective?
So the gel that we use, it's actually a high viscosity resin-like material. As said in the presentation, it's acrylic based, which actually makes sure that it's really nice to sand. It actually sands really well, also because our materials are thermoset materials, and they usually sand very nicely, because when you sand them, they don't melt. They actually they ablate. So you remove material, you never melt the material, which makes that you can get to very smooth results very fast. And that makes it also ideal for further post-processing, such as finishing with fillers and paints.
Great. Well, I mean, the items you're showing us in the presentation, they're just absolutely incredible. And looks like the Spider-Man is a popular one. And we have a viewer asking, what is the material of the Spider-Man?
Oh, so it's composed of Demon Gel. So it's a photosensitive acrylic-based gel. And we formulate it in all kinds of formats. So we have gels that are more, let's say, focused on economic performance. So cheap gels that are gray, like Demon Gel 90, but also transparent or almost transparent gels like Demon Gel 300, and also a very strong gel that you could use for engineering purposes, like Demon Gel 400.
Great. Well, speaking of materials that Massivit uses, does Massivit ever work with 3D concrete or always lightweight materials?
So the materials we currently have, they're just lightweight materials. We don't have a concrete material in our lineup currently. However, the existing materials, you can use them to print molds for concrete objects. Well, you would print the mold, and then you would separately pour concrete into the object, secure it, remove the mold, and then you have your concrete part. So it is a possibility. We do have a application note on that exact process. So if anyone wants to know more about that workflow, we can always send that. Yeah.
Right. And how much variability do you have? How well defined are mechanical material properties for your more structural gels?
So of course, whenever we engineer a gel material, we look at certain objectives. Like I said, we have our Demon Gel 90, which is more focused on cost and to produce economic parts. But we also have our Demon Gel 100, which we formulated to be like partially translucent in order to make appealing objects that are equipped with lighting and lighting effects. So it really depends on what you want to do exactly. We do have a gel suitable for specific applications. So if you need an engineering, if you need gel for an engineering application, let's say to build a cockpit, we would say, okay, you can use the Demon Gel 400, which gives you the strength. If you need to make a window screen for that same cockpit, we could say, okay, well, you can use Demon Gel 300, so you have the transparency. So really, there is a specific gel for each application.
Got you. Well, and how do you typically strengthen the 3D printing, the 3D prints?
So as you have seen in the presentation, we really focus on printing big hollow parts. Since they are hollow, you can actually, well, strengthen them however you want, or you can use the printing material to basically scaffold your object and give them extra strength that way. But you can take it much further than that. You could also build a metal skeleton to put into your object and then reinforce it further with polyurethane foams. But the most important thing to remember here is that you have a great deal of flexibility to post-process your parts. And you can really gear them towards your specific application in terms of strength to, well, finish them.
Great, thank you. All right, now is the gel poisonous? Which I guess that's an important question there. Does the printer have built-in ventilation?
So of course, in its uncured state, it's better not to come in direct contact with the gel. But the thing is, during printing, we instantly cure the gel and it basically becomes inert. The VOCs, so the volatile organic components that are produced during the polymerization process with UV light, those of course have to be evacuated. And what we have in every printer is a hole in the roof where you can connect your facility's air ventilation and air extraction to. But you could also purchase a separately sold carbon filter unit to place on top of that hole and extract the fumes and absorb them with the carbon pellets inside.
Okay, and could you discuss how much unsupported overhang you can achieve while printing?
Yes. So unsupported overhangs. Actually, we are very good at printing 90-degree overhangs. Actually, we don't need any support to print 90-degree overhangs, which is unique in the additive manufacturing world, I would say, especially with a process like ours. And let's say that of course you have to keep, we live on planet Earth, we're a bit bound by gravity. So at a certain point, you're not necessarily fighting against the overhang itself, but you're fighting against the weight that is placed on the overhang. So at a certain point, of course, it's sensible to place some supports to protect your object from gravity and not necessarily from the overhangs that are produced. If that is more or less clear.
Our next question, are 3D prints ever used to create the molds for a more traditional casting?
Oh, yes, all the time. Actually, we have a few customers who apply our technology in that way and who use our technology to produce molds for limited series production. Yes, that's definitely possible.
And do you ever offer the option to purchase or request samples of your different print materials to examine for product suitability?
Of course, just drop us an email and we will make sure that you can receive some samples.
Great. And someone would like to ask, is the gel tintable? So I guess color options with the gel.
Oh, well, actually, the preferred way of is actually post-processing, because if you would tint the gel itself, it would give you trouble during the printing process because our gels are tuned to a specific UV power and also you would end up with some pollution in the material lines. So the best way to color prints is to, well, add color in post-processing by painting them.
Okay. We have a couple questions on cost. How much does the unit cost and how long is the lead time to get one?
Depends on the options. We have a wide variety of printers available. The lead time is quite short. We have stock in both in Europe and in the US in our warehouses. So we have local warehouses. And the cost mainly depends on the machine itself. So we have let's say our entry-level machine, although it's not entry-level in the fact that it's a fully professional machine that can run unattended and has some remote controlling options. But this one would be the Massivit 3000, which has one printing head. and can print with a select number of materials. In this case, our most professional option, or our most advanced option, let's say, would be the Massivit 5000, which has 2 independent print heads, so it can print simultaneously 2 different models, and can print with our Massivit Dimengel 110, for instance. So it allows you to print in very, very high resolution as well. But if anyone's interested in some pricing options, they are free to send us an email, and we can get a quote for them suited to their needs. It's not a problem.
Right. And what is the material cost per kilogram? Does that, I guess, also depend on the specific material that's selected?
Yeah, it depends on the specific material. Also, you know, our material prices, they start at around, let's say, 50 euro per kilogram. But it's very difficult to compare it in a one-to-one pricing with other materials, because as we print hollow, basically you don't need a lot of, let's say, material to be used in a print. So there is no actual infill, there is no waste. You basically only print the outer shell, which allows you to be quite economical, let's say, with the material cost and the material.
Great. Well, thank you, Peter. Thank you, Fabio, so much for answering those questions. I don't know if we're about to reach the end of our webinar today. I didn't know if you had any final thoughts, anything else you wanted to throw out there for all of our viewers today.
Well, no, I hope that everybody enjoyed the webinar and learned something from it. And as I said before, and as as we're showing here in the slides, you're always welcome to visit us at our booths, both in Germany or in Orlando next week, to see the machines up close printing. It's always nice, sometimes people pop in during a trade show at the before noon, just to see a print that just started, and by the end of the day, basically our engineers are ready to take out the fully finished print out of the machine, and people are always amazed by the speed and the print quality. So if you have any questions, feel free to pop by or send us an email. We're available.
Excellent. Well, listen, everyone, thank you so much for joining us, and thanks for bringing up the expo. It's next week. We're all very excited here at IAAPA. And Massivit's booth, which I'm going to have to stop by for sure. I believe it's booth 1357. So make sure everyone headed to Expo next week comes check that booth out and say hi to everybody. Well, that includes today's webinar. I'd like to send out a huge thanks to Pieter and to Fabio for the presentation today. Fascinating insights. 3D printing is very interesting, and I know very fascinating to a lot of our members as well. Just a reminder that today's recording will be available soon on IAAPA.org. So make sure you check that out, along with all of our other webinars and EDGE sessions from past expos that you don't want to miss out on. And thank you for attending today. We hope to see you all at a future IAAPA webinar. Have a fantastic day, everybody. See you at Expo. Bye, everyone.